Hello, one and all. I'm Finley Braithwaite, Assistant Professor of Media Production as well as Professional Music here at the Creative School at Toronto Metropolitan University. It is an honor to welcome everyone as the facility host of Breaking the Boundaries of Stereo. Before we begin, it's important that we acknowledge the land we're occupying today on this National Day of Truth and Reconciliation. Toronto is in the dish with one spoon territory. The dish with one spoon is a treaty between the Anishinaabe, Mississaugas, and Haudenosaunee that bound them to share the territory and protect the land. Subsequent Indigenous nations and peoples, Europeans, and all newcomers have been invited into this treaty in the spirit of peace, friendship, and respect. Welcome to the Chrysalis at the Creative School. The Creative School, as a faculty here at Toronto Metropolitan University, offers 27 top-ranked undergraduate and graduate programs in creative disciplines, including performance production. We got any performance production students here? Yeah. Professional music? Yeah. And media production? To name just a few. So here, students are immersed in an environment that puts them in close contact with cultural, entrepreneurial, and industry leaders, integrating real-world experiences into every aspect of their educational journey. Today's event is an example of the experiences curated and cultivated for this community. The Chrysalis is a multidisciplinary performance space shaping the future of interactive and creative experiences to captivate new audiences. In reimagining the old Ryerson Theater as a future-facing incubator of creative performance experience, sound would have to play a huge role. We needed a cutting-edge sound system that would, frankly, kick some ass. Adamson delivered. This cutting-edge system that can be configured either in a spatial or a traditional stereo array has added a breathtaking wow factor to the space, a dimension sorely missing from the previous iteration. I'll let Jeremiah Carney get into the details, but let's just say the results speak for themselves. This sound system provides a spectacular canvas for artistic expression for a wide range of performances in this venue, including student productions and residencies of leading practitioners and producers of performance. It's icing on the cake that Adamson is just down the road in Port Perry, Ontario. We benefit greatly from your expertise and your continued contribution to our community. The idea for this event came about in planning the Toronto AES Expo here on campus earlier in June. Immediately, we thought of the potential for Adamson to show off this brand new installation to the wider community of audio professionals. It wasn't to be, as we were already fully booked with productions looking to engage with the newly reimagined Chrysalis. We were determined, though, to follow up and connect the space and audio technology with the audio community here in Toronto. Earl McCluskey and Anthony Kazoob of the Toronto AES, thank you for making this happen. Thank you to 𝐿𝐴𝐶 Lightwalla for your leadership and vision in reimagining the Chrysalis. Scott Martin and Jasmine Au, thank you for facilitating and organizing this event here on campus. You two make an excellent team. Most importantly, thank you to Adamson. This sound system is a real game changer for our students, faculty, and the wider community of creative professionals. With this, I'd like to welcome to the stage my colleague and friend Anthony Kazoob from the Toronto chapter of the Audio Engineering Society. Get up here, you rascal.
Cheers, Finley, for that introduction. As you know, this is an AES event, so what does the AES stand for? Well, we're the Audio Engineering Society. Sometimes that's a capital E, and sometimes that's a lowercase e. But what we're really trying to do is people who want to know more, and we want to create these presentations and capture them right now I think we're streaming, we're live on the YouTube. We unite audio engineers socially. Within our allied arts, we collect, collate, and disseminate scientific knowledge that furthers all fields of audio engineering. The AES aims to empower people of all ages, participation in a healthy, safe, open community presentation such as this. We want to learn audio engineering through events, presentations, networking, and mentorship, just like this event here. The Toronto AES can be reached at torontoaes.org. This is our local landing page. There you'll find a catalog of some of the events that we've produced in the last few years. We produce 10 events every year, and with that, we have a variety of topics. I heard, there's a lot of music students there. There's a lot of media students, but the music industry isn't the audio industry. The live sound industry isn't the audio industry. There are many, many facets of the audio industry, and we try to give a platform for everyone to participate in. We have a YouTube channel, like I said, we're streaming, and during our COVID time, we learned how to really do online events that can be shared throughout the globe, and we have continually repeating traffic to those. Well, why would somebody want to become an Audio Engineering Society member? We do have student memberships, and we also have other levels of membership, but really, like, it's an atmosphere for mentorship with industry's leading minds and practitioners. I know that most of the top audio technicians, design engineers are AES members. And really what that does is it builds a network of peers. Just seconds ago, somebody said, "Hey, Anthony, do you know where I can get a..." And then I looked over and pointed him to somebody and said, "Go talk to him." And sure enough, boom, networking. That's really what collaboration is all about. And we connect people who design and people who build and people who ultimately sell this stuff. And really, this is about tools, and we are tool makers. And we want to share knowledge and share experience. Of course, our pizza was provided by some of our sponsorship. Adamson is up there. We've got Gear Audio, avshop.ca, Sonotechnique, Adamson, Lawo. And these are our trusted community partners and people and companies that participate with us in enabling us to share this type of information in venues such as this. Again, TMU has been fantastic in giving us an opportunity to showcase our community involvement and community spirit. And the University of Toronto has also been fantastic in providing us space to gather and meet and share this information. Our executive, we're a volunteer organization. I like to say that we're like an audio improv group. We talk about topics. We come up with ideas. There's no bad ideas. There's just ideas that we have to put off. And then we come up with a meeting topic. We talk to our industry contacts, and we bring them in there. And we create meetings such as this. Our executive, I'm chair, our vice chair is out here. Our secretary is, I don't think Alan's here. Our treasurer, Jeff, is here. We have Mariana and Brian and myself. I've been taking care of the website in Earl's absence, but Earl has been more actively involved in the last little while. Earl McCluskey has produced this event, and we look forward to his involvement. Angeli, Dan Marboquette, James and Najib is here, I think somewhere, and Warren Beck. So if you want to be involved, it's very simple, Toronto AES at torontoaes.org. You're welcome to send us an email. If you're interested in producing an event, or if there's a topic you want to know more about, that's the beauty of these. It's like, it's not a finite thing, it's a choose your own adventure with the Audio Engineering Society. So with that, Jeremiah is here, and I'll welcome Jeremiah. I don't have a bio, but that's okay, I'm just gonna make it up. Jeremiah is with Adamson Audio in Port Perry, and we're very privileged and lucky to have our neighbors really, being involved in events such as this. So welcome to the stage, Jeremiah.
Thank you. Okay, great introductions. Thank you to everyone for showing up. I really like to see that there's a lot of students here, because at the end of the day, the system that we're going to try and show you through today is really for you guys to get involved with and utilize the technology that we've put in here for the future of what live events should be. I don't have a bio, but I've got a little bit of a company introduction. So those of you who don't know who Adamson are, we have been around for over 40 years as a loudspeaker manufacturer. Started in the 80s on the, excuse me, I hate public speaking, and I have to say it out loud because it helps me get beyond it, because at the end of the day, I'm an audio technician like the rest of some of the people here, so it just takes me a minute to get into the groove of doing this. Then you won't shut me up, I promise. Okay, so we were founded in the 1980s in Vancouver, Canada. Our founder, Brock Adamson, is still part of the company with us, and he was on a quest to improve the sound of loudspeakers that were in the market at the time. And like all of these things, when you start looking at something very closely, you find there's a lot of things that you don't like about it, and the refinement process starts. Brock's a very brilliant guy. He's come up with some amazing patented inventions in our industry that's really changed the face of loudspeaker as a whole, not just for us at Adamson, but also the greater community in the loudspeaker world. So in the 1980s, he refined a new way of doing mid-range or mid-band, you know, the vocal clarity range of loudspeakers. He came up with a loudspeaker that's here in the picture called the MH225. And behind that, there was quite a lot of technology. There was new transducer technology that he'd worked on with new materials and things like that, as well as new waveguide technology that he commercialized and brought to the market with, again, networking, talking to people who had published papers and stuff like that within audio engineering societies like this. So that's why these are really important. In the 1990s, there started to be a big shift in the way loudspeaker systems were built and deployed. We saw the birth of the line array, which is a big part of what we're going to talk about today with the system here. We weren't the first to market, but we were damn close right there behind. And really what we did is we looked at all the technology that was in the market and refined upon that. We looked at what other manufacturers were doing, and we found better ways, well, we believe, better ways of doing all of these things that really brought the message closer to the audience. And really, all of this is working on making sure the vocal clarity, the message that the person is being amplified to tell the audience is clear, crystal clean, and not altered by, you know, physics. The 1990s also saw the move from the West Coast to Ontario. This is where a lot of the manufacturing happens in North America with the automotive market and all that kind of stuff. So in the quest for finding the right materials to be able to create these high-grade products, the move to Ontario was necessary at the time. Moving into the 2000s, the innovation never stops. We were one of the first manufacturers to ever come to market with a 21-inch subwoofer. The T21 shown here is well known around the audio circles as being quite the beast of a subwoofer. It was also a patented design. It was a symmetrical drive technology. It was the first time anyone had done that kind of arrangement, and there's all sorts of patents and papers that have gone into all of this. So it's not just some guy putting something together in a shed. All of this has been well documented and written about. Fast forward into the 2010s, we moved from Ajax to Port Perry, I think late 2000s, probably, I think it was about 2005. My colleague here, Brian, is giving me the hand signals. He's going to hook me off stage if I say the wrong thing. So we moved to Port Perry because the space became a necessary thing. If you're going to manufacture a large product, you need a lot of space. This is the building as it stands right now. So that was built in the early 2000s, and it opened in about 2005 when we moved there. But in 2010, with the success of products like the E Series, S Series, and our dedicated installation line with IS Series, the need to expand was necessary. So in 2014, the area in green was opened for the first time. It was broken ground. It opened in 2015 or 16 and increased our production capacity quite a lot. Now, a lot of the product that we make, might not see much of it in your backyard when you're talking about the E series and stuff like that, but it is very well accepted all around the world. So we don't just sell within Canada and North America, so all this stuff gets shipped all around the world. So we've seen it with E series, the success of E series reached across Asia, Australia, it's gone through India and China. It's very well accepted through Europe, as well as a lot of tours that have picked it up and taken it through the 2010s till now. Okay, now we get to where we are today. So the 2020s, obviously some really big things happened for all of us in the 2020s, but it didn't really slow us down as far as research and development and working on production and stuff like that. During this time, we were working on more transducer technology, as well as our third generation of large format touring line array. And that was released in 2024 with the Divergence Group loudspeaker line and the VGT flagship line source product that is shown here in the drawing. To support this, I've actually dropped a little bit of information. With each of these generations of line arrays, there's been a new software that's gone with it for control and design, and I'll talk a little bit about the current software in a moment. But also in the 2020s, we decided that spatial audio was something that we were very much interested in, and we partnered together with a company and released the Fletcher Machine. Also during the 2020s, again, it's been a very busy 5 years now, we're halfway through. We did actually add more to our building. As you can see here, we've added this side wing on, and that was launched also 2023, 2024. We've added a full manufacturing line just for powered electronics. And the big push for that is, again, all loudspeakers need some kind of amplification behind them. And I'm going to talk about all of the different, a few of the different types we've got now. But again, the big move to this expansion of manufacturing was to help support not just the products that you're hearing today, but also our recently released new line of integration amplifiers. Okay, so breaking the boundaries of stereo. My goal here is to show you the new technology in place in a system that is actually working and ready to be used, right? You could rent this tomorrow, or if you've got a class project that requires it, it is here at your disposal. Oftentimes when we do these demonstrations, we're setting up something temporarily in a space and trying to make that work. So it's really, really encouraging to be able to show something that's here at your disposal. So what does it mean by breaking the bounds of stereo? More and more now, there is a push in the live event experience market for immersive. In fact, it's probably, I would say, become a bit of a buzzword. Immersive, in our opinion, it describes something that's happening right now, right? You should feel immersed in any event, and if you're not immersed, then there might be something missing. As far as the audio component of this, we actually prefer the term spatial audio. So an immersive event, you could be listening to a single person talking without any loudspeakers. That should be engaging and immersing. Spatial audio, it talks more about the technology. So the differences between stereo and spatial. In a typical stereo scenario, it's all about creating space, right? When we build a mix, whether it's just one person talking or a full band on stage, we're trying to create a kind of a front to the audience to be able to hear everything equally as it's intended by the musicians or the performers on stage. Oftentimes, the tools that we have available to us are level, equalization, compression, and most pan, right? So being able to move something from left to right as we see it. Because we are, as much as we rely on our ears to be able to localize things and, that hunter aspect of hearing, someone creeping up behind you, we are still very much a eye-to-ear visual and audible creatures. So in a stereo system, or traditional system that we'd see in most venues, whilst it's never going to sound bad unless it's, it's all source material, there is a stumbling point when it comes to be able to create space in your mix to make all of the performers that you see on stage fit to where they are. So when we're talking about a stereo system, when you start to do any kind of left to right pan, if you were to pan all the way to the hard left or the hard right, you start to really shift the image quite a lot, to the point where it could be detrimental in a larger system or in a larger venue, that if you were to pan something all the way to the left, everyone on the right side of the house might lose the audio, or it's moved far, far away. When it comes to that sweet spot of mixing and listening, you typically would always find the front of house or mix engineer in the middle section, because this is where you're going to get the most localization in any stereo mix. Right? So again, listening to headphones, it's not a big deal. But again, when you're talking about broadcasting live audio to a large audience, making sure that you don't miss anything is quite imperative because of physics. In a spatial environment, the idea is that we want to increase the area of localization. Right? So again, we've added more speakers, and I'll talk a bit about that in a moment. But the idea is that with this style of system, and again, I've got a couple of gags, and some of them might go wrong. With a spatialized system like this, ideally, if I go into spatial, you should be able to, I'm going to look for some nods, hear me move around. Am I moving? Am I moving? No, I might have to hit a button again. I am moving? Okay. So you can see the difference being that if I start to move around on the stage, that now, ideally, you're looking at me because I'm walking around, but you probably, if you were to close your eyes, you would want to start to tend towards where I'm standing. So I'm going to try and illustrate this a couple of times. Okay. So I'm going to use a single drum sound, and I'm going to play this a couple of times, and if anyone has seen my presentation before, I apologize if I play some of the same material. It's good to hear it in different spaces, trust me. So I'm going to play a track first in stereo, and then again with the spatial system. So that's stereo. And of course, this is where it all falls apart on me, I'm sorry. Okay. Again, I've got quite a lot of stuff going on here because I've got a lot of things and toys that I want to show, and I don't know if I'll be able to show it all. Did we hear a difference? You can hear when it goes into the spatial, it probably all panned all the way hard to the left, right? I'll do it again and again. Towards the end, I very much encourage, if you want to listen to it again, I have some stage monitors up here where you can actually play around with it and hear it a little bit closer if you want to. Okay. Again, I'll play a couple of different tracks as we go, so hopefully you get to experience it fully. But now I'm going to bore you with some of the technical specifications behind this system. So as Finley mentioned at the beginning of the presentation, the system was designed and sold to the venue as a configurable system. With spatial audio being quite new, there is some people get a little hesitant. So being able to provide multiple different setups for the system was very important. No matter how it's configured, the loudspeakers that we're using in this system are quite interesting. We're using our CS series of loudspeakers. They are an intelligent loudspeaker, meaning that, in fact, nearly all of the loudspeakers that you are hearing on stage and in the audience actually have electronics inside of them that are built here in Canada in our manufacturing facility. The CS7 is a dual 7-inch line array. It's very small. As you can see, we've got 5 arrays above us. We've got about 8 in each array, with a total of 40 CS7s in the venue. It is a two-channel Class D amplifier, meaning that it does automatic switching in the amplifier, so it's very, very efficient. It's not storing up and drawing a lot of energy the whole time. It stores it up and then deploys it as it's needed. And it also has inbuilt digital signal processing in it, so DSP built into the box. The other thing that's worth noting is the loudspeakers are also Milan ready. And if you're not familiar with Milan, Milan is a networked audio protocol based on an IEEE backbone. So it's also referred to often as time-sensitive networking, with Milan being an interoperability standard specifically for the audio industry. For low-frequency content, we're using the CS119. It is a single 19-inch woofer subwoofer. We have 6 stacks of them, which is a lot for this room, and it's because we're actually using a cardioid preset to minimize the low-frequency buildup on stage and maximize the amount of energy in the room. The reason that we've gone with 6 stacks is also so, as part of the spatialization, we can utilize the low-frequency content if you need to be able to have some kind of movement to it. It also is a Milan-ready endpoint or loudspeaker, so it is all networked together. In fact, I would say there is very little analog in this entire setup. I'd say it's pretty much just in from microphones to stage boxes. For front fills, we're using IS7Cs. These are not powered. There's actually a second amplifier in a room that is being fed from the Milan network. But they are all discretely on their own, so they're not daisy-chained together or anything, so they're actually part of the spatialized system. Again, for the loudspeakers with amplifiers and DSP in them, this is a little bit about the DSP. There's quite a lot that we can do with these. There is input selectors, so they can take analog or Milan, redundant Milan AVB audio. There is quite a lot of user possible settings in there. So you've got typical delay, mute, polarity, and filter sets, so you can use those for calibrating and making tonal adjustments to your loudspeaker system. A good portion of the DSP is actually locked off from the user, and that's used to be able to store the preset for the loudspeaker, meaning that when you plug in any of these powered loudspeakers and plug a line level signal into it, you don't have to worry about making sure that the right preset's recalled, that there's going to be any kind of things that could damage your loudspeaker system. But also as part of this, there is a section of the DSP that is reserved for our optimization, which I'll also talk about in just a moment. All loudspeakers have been connected together using standard Cat5e cabling. Each loudspeaker has daisy chainable networked, meaning that you can plug multiple speakers in a daisy chain from each other, and it minimizes the amount of switch ports that you need to use. The amount of cabling is vastly reduced, and it just generally makes things a little bit more streamlined. Every loudspeaker in this system is patched to a redundant pair of network switches. In this case, we're using a pair of Luminex switches. So we've got a primary networked audio with control, as well as a secondary networked audio in case anything happens. There's also the ability of having an analog failover, meaning that in a fully redundant system, there is 3 levels of redundancy. So primary and secondary deal with the 2 networks, and then analog being the 3rd. And that's being matrixed out and split out through the NDS panel, which is shown here on the screen. And what this does is it takes the primary and secondary networks into a rack, which I'll show in a moment, and breaks it down to be able to make primary and secondary on one cable. So we were able to leverage a little bit of the Ethernet technology here. The loudspeakers are a 100 meg network device. There is switching fabric in there. That's how we're able to do all of this daisy chaining. But because we're only using 100 meg, we're actually able to leverage half of the cabling within the Cat5 to do 2 networks parallel on a single cable. This means that we can, again, vastly reduce the amount of cable used in a loudspeaker system, minimizes the amount of switch ports that we need, and I had a third point that's just escaped me. It'll come back. So all of that network technology is in 2 distribution racks, and they are actually stashed above us in the ceiling. Don't worry, they're tied onto trusses up there. And this is just a convenient touring-grade rack for being able to reconfigure. Again, we chose a powered loudspeaker system, again, because of its configurability. We started off with a stereo system in this room, and then I think about a month later, we switched it back to the spatial audio, and it's been like this for now. It's been well accepted, and I really have to thank the TMU team here for putting in a lot of work into making this work quite well. At the front end of the system, we have our Adamson gateway, and this is a 16 by 16 DSP matrix. This is managing any additional consoles. It's also bringing in some audio from QSYS and a few other things for events that aren't necessarily spatial. So if we're using a stereo system, this gateway will do all the matrixing from the Digico through taking your left and right and matrixing it to the right area. It has AES and analog switchable on the input and the output on 8 balanced XLR connectors on the back. It is also a network switch. So there is 3 primary, 3 secondary Cat5s, and then there's also primary gigabit fiber optic as well as a secondary. And it's actually become quite useful in here because we're actually using it to network quite a bit of the stuff at front of house in the interim as the theater is starting to be upgraded over time. And then lastly, in the loudspeaker system itself, the software that we've used to put all of this together, to design it, to control it, is our Array Intelligence software. And we just released a 1.3 build of that last week. The Array Intelligence software is built on 3 generations of software that are based around loudspeaker design. It started off as a software for aiming line arrays, and it has quickly morphed into quite a in-depth 3D and 2D design suite on its own. A lot of the simulation stuff that I'm going to show in a moment has been done within this software. Array Intelligence also is the main control platform for all of the loudspeakers. It's kind of like our network, overall managing tool. So it sees all of our loudspeakers. It uses an AES 70 protocol to communicate with all of the loudspeakers. It's really good at, putting all of the arrays together and managing things in much more simpler blocks rather than just looking at a page of 60-odd loudspeakers on a network. So all of the calibration was done within Array Intelligence, as well as any metering and monitoring that we might need to do during a loudspeaker system. Okay, so just quickly looking at the stereo setup, and I won't dwell on this too long, but I just wanted to quickly show a little bit about our optimization. With the stereo system, we ended up at about 12 CS7s per side, which gives us quite a nice long line source for a little bit more low-mid control. When you see the loudspeakers, and you can see that in all of these little dots, they're basically like little virtual microphones. Our software will measure all of the direct audio coming from the loudspeakers over the distance of the venue. And then within Array Intelligence, we have an optimization calculator that can take all these virtual microphones and apply a customized, tailored filter set for each individual loudspeaker in the loudspeaker system. And then when it deploys that, as you can see, it's brought all of those different listening positions, all of those different microphones much closer together over the entire spectrum. Meaning that using this tool, now you're going to have less and less where it's going to be maybe too loud at the front and maybe not loud enough at the back, but now each listening position on axis with that array is now going to be much, much closer in not just level, but also tonality. Our optimization works like this. When it looks at the entire spectrum of audio, it uses magnitude to calculate the high frequency, so anything that's sibilant C, it'll use level to either tame it, like lower it or raise it. In the lower midsection, it's going to use more of the phase to adjust each parameter as you're moving further and further away from the array. And then the very important section, which is the vocal coverage range, it's using a mix of phase and magnitude to create individual FIR filters for each loudspeaker in the array. So as you move throughout the listening area, it should be more tonally smooth. Just a quick look at the 3D heat map. And again, looking at the top down, again, you can see the hallmarks of a typical stereo loudspeaker system where you can actually see the two little, on-axis, very beamy areas that are very common with a left and right loudspeaker system. So again, showing that if you were to pan hard or pan left, you can start to see that these heat maps would start to show that if something was all the way to the right, then the left might not be getting anything. So we're not actually using the stereo system in here. As you can probably see above the lights, we actually have a system that looks a lot like what's on the screen right now. So we've got 5 arrays of 8 CS7s. They're in circuits of 4, again, minimizing the amount of cable runs back to the distribution racks. We've got the 6 stacks of subwoofers down the front that are arranged in a cardioid subarray. And then we have some front field coverage for anyone that's kind of in the close section. Also, as a bit of a treat, on stage at the end, if you're interested, I do have some of our brand new MG10 stage monitors here. And I brought them down really for me to play with, just because I wanted to hear what it would sound like with some toys that I'm going to show later on. So when you put up a whole bunch of arrays like this, you can't use a typical channel-based mixing system to be able to make this work. If you were to do that, you would find yourself quickly getting into a lot of summing and canceling as you start to matrix things to each array. So we really need a processor in line here, and that's what we're going to show now. The Fletcher Machine is Adamson's spatial audio rendering engine. There's a few different models, and they're listed on our website if you're interested, but I'm going to specifically talk about what we have here in place. It's hidden. It's sitting up amongst all of the technical equipment at front of house. but it is our Fletcher Machine Traveler. It is AVB Milan. They're both the same thing, really, and MADI. So we're able to talk to it through standard MADI from the Digicoes. So all of the incoming microphones and channels of stuff that's coming into the Digico can be discreetly sent via MADI. But it's also got Milan, so it's able to directly send audio out to each of the loudspeakers. In fact, in this current setup, I've actually got another matching Digico on stage here with a Milan card in it, and we've actually got quite a bit of networked audio traffic going all the way around the room. It's super low latency, again, because it is dealing with time calculations. We need to make sure that it's not adding too much. So the rendering engine just by itself is as low as 1.33 milliseconds without any kind of spatialized calculations on top of that. The unit that we have here is 64 inputs coming in, and then up to 32 outputs of localized loudspeakers, whether it be 8 loudspeakers on one channel or one speaker on one channel. We can have up to 32 loudspeakers, sources in this room. We use rendering layers to be able to render audio into each different section of the loudspeaker system. So I have a layer for my phone system above me, I have a layer for my subwoofers, and we can have up to 6 rendering layers with this particular engine. With our larger Stage Plus, you can get, I think it's up to 12 different layers with up to 128 by 128 channels and objects in and out. It's very small. The Fletcher Machine Traveler was designed to be able to be portable, so it can be put into a nice little road case. And on the back of it, it does have redundant Milan connections as well as the remote control connection, all through Cat5. So for the loudspeaker portion of this, we had a total of 40 CS7s at our disposal to play with. With the stereo system, we're only doing 24, 12 a side, occasionally more. I think one time we've done up to 14 a side, or 16 a side. But for the spatial array, or the frontal system as we would refer to it here, we've had to go quite a lot shorter. But the benefit is we've got more loudspeakers covering on the horizontal, meaning that we actually had to use a bit more splay than we would use on a stereo array because each loudspeaker has to cover further. But again, we now have 5 arrays, so headroom becomes less of an issue even though the arrays are much shorter in length. But we did definitely leverage our optimization here to really clean up how it's performing over distance, so each loudspeaker array is sounding identical and that there's not too much deviance as you're going front to back in the entire system. So just for comparison, this is what our stereo 3D simulation looked like, looking down. And then this is what our frontal. Now, there's a little bit of inaccuracies here. This is all loudspeakers playing all the same level at all at the same time. In reality, that's not actually how it happens. As you can tell right now, I'm spatialized and I'm in one corner. If I was to move over here, then obviously I'm going to move around. And then as you start to stack multiple objects in multiple places, your headroom gets spread over all 5 arrays. But the reason I've shown this is because it gives you an idea if the contrast works. You can actually start to see from that center, because we've taken back that center channel now, we're starting to see that ripple rounding effect of a wave front coming out from this frontal system. So, what does the Fletcher Machine do? Well, it employs an object mixing style of rendering. And it's best shown with this little animation here, which is taken from the Fletcher Machine remote. So the way object mixing works is it takes all of the incoming channels and it turns them into objects. If we're looking at this as a typical stereo summing style of mix, and I use the word summing Because if you have a whole bunch of audio sources coming in, represented with those very faded looking waveforms, for a console like this Quantum to work, as you start bringing all these sources in, you need to start layering and stacking and summing to get your mix together. So that typically means an engineer will use a lot of EQ, maybe compression, and some of those tools to create some depth as all of those sounds start to get layered on top of each other in the very limited stereo field. And so you end up, whether it be a stereo or a left, center, right system, with a very, very, full, busy sound and a lot of, plugins and EQ and stuff like that to try and make it all fit. So we're trying to simplify that. Object mixing works a little bit differently. If you take a single instrument, like that drum track, for example, and you put it somewhere in the space, the Fletcher Machine engine calculates the time arrival from every single object to every single loudspeaker in real time. And not just the time, but it also uses amplitude too. So if you have a saxophone here, as that instrument starts to play, it's going to localize or appear to us louder at the closest loudspeaker. It's working kind of like a lens. Now, if we were to use discretely time and amplitude, then as we start to move around, we're going to start to find that our objects will start to separate and move apart. It's very realistic. We know that we hear when an ambulance goes past us the modulation effect as time moves. But in some cases, if we're trying to really tighten up a bunch of musicians playing, using every millisecond of that time might not be ideal. So we've applied a rendering mode by default, whilst both options are available to have full time and full amplitude. We have a minimum delay mode, and what this does is to make the source sound much closer and give the mix engineer a little bit more control. The calculation truncates the time from the time arrival to the first loudspeaker and applies that gradient effect with the arc shown here to all of the loudspeakers. So basically it gives it the feeling of it being a lot closer, but still having the benefit of the localization effect as you move it around. Okay, so I've talked a lot about the Fletcher Machine, but how do we use it? The Fletcher Machine is controlled by a piece of software. You can see it, it's up here on my computer screen here. It works on Mac or PC, and it is essentially, it's just a window remote control into that Fletcher Machine traveler box that I showed earlier. And that communication can happen over Wi-Fi or a wired network. When you open the remote, it looks a little bit like this. Again, it's very audio friendly. It looks a lot like most any other mixing console application or console or VST or DAW at home. There's faders, you can see audio coming in, but most importantly, you're drawn to the main object movement in the middle. If anyone is interested in trying out our spatial audio, there is a free version of the Fletcher engine that you can download from our website. It works on any computer with any sound card, and it uses the same remote. In fact, the same remote works with all different levels of Fletcher Machine that we offer. But the free version at home gives you the ability to use either a loopback software for playback, and either the headphones on your laptop or a small speaker setup in your home studio to be able to start working with some of these tools. In fact, the free Fletcher Machine, as well as all of the engines, actually have binaural rendering built in now. So again, if you are using something at home, you can do it in headphones. And it gives us the opportunity to do pre-production without needing to set up a full loudspeaker system in the field. Okay. So when we're talking about object-based mixing, I just had a little bit of an example that should lead into some listening. The Fletcher Machine is an object-based mixing system. So the idea now is that all of your channels and microphones on stage would be placed out in front of everyone, and it would look a little bit like this. So when you're looking at the remote control software, you can see where the loudspeakers are in your system, but you also get to play around with where all of your objects are. Okay. I've done quite a bit of talking. Are we ready to listen to some stuff? Yeah, I see some nods. Yeah, no one's nodded off yet. Excellent. Okay, I missed a track, so I'm going to play 2 tracks back to back. As I'm playing them, I do recommend trying to experience them in a few different places. I'll play a little bit of the track first in stereo, and then I'll stop it, go back to the start, and then redo it with the spatial audio. Okay. Okay. Did I mute myself again? Yeah. keep muting myself. There you go. Never give an audio guy too much stuff to play with, because we will mess it up. We're really good at that. I'm particularly good at it. Okay. As I said, I've got quite a lot of technology up here to show, so I will always continuously trip over myself as I do so. But yeah. The next track, I'm actually going to immediately go into another track, because I was supposed to play that one a little bit earlier. And the next track is more of a classical piece, or it is a classical piece. And that was the example that I showed here, where if you would have a bunch of musicians on stage, how does that translate into the audience, right? So this one's it should be a little bit more jarring if we start in the stereo for this. So again, once you put it into the software, all of those microphones now get an object position like you see in the overlay, and that is how it's then presented to the loudspeaker system and rendered. So we're going to do one more listening piece, and then I've got a bit more technology to talk about. And this, let's see how quickly I can trip over myself here. Okay. Okay, and now we're going to play the same track with the full frontal system. Okay, what do we think? A lot of people moved around. That's good. It's nice to see people moving around. Good, good. Okay. So now you understand a little bit about what the technology can provide from an audio perspective. And now the fun part. Now we get into all of the new tools. As audio engineers and audio professionals, we spend a lot of time reading about things like plugins and EQs and all that kind of stuff. Well, I'm going to actually propose a bunch of new tools that are not necessarily immediately audio, but are related to what we can do here with the Fletcher Machine. The Fletcher Machine remote and the engine, or the system in general, can handle a lot of different communication protocols. Again, we talked about this being a networking event. It's a networking event in so many different ways, with it networked audio, networked control, and all of that fun stuff. The Fletcher system can talk OSC, Open Sound Control, to anything that can speak OSC. Can also speak ADM OSC. In fact, we were actually recently co-authors of a paper for AES on ADM OSC. It can talk MIDI and HUI and timecode. So all of those things make this a perfect tool to put in a show environment that is programmed and very, very much involved with other departments in a theatrical environment. There's console integration, and again, we have two consoles, two Digico's here that both have it running. It is native to the Quantum and SD range, and I think Ian from GER is wandering around if you want to bug him about more Digico-related stuff. And again, I can actually show a little bit of how this is working. There's a dedicated plugin, so if you are doing any pre-auralization at home and you want to automate stuff into your DAW, there is a VST and AAX plugin that you can put into your system to be able to control the movement of any audio tracks being fed into the Fletcher system. And there's a direct integration with different tracking systems. And as you probably noticed, I'm able to walk around, and in just a moment, I'm going to invite a special guest on stage to talk more about that. Snapshots, so again, it is just like any other loud mixer, any other mixing console where I'm able to build an entire show from snapshots. In fact, I've been doing that, and that's what I keep tripping over up here because I've got several different stream decks in different locations trying to fire different snapshots at any given time. But it just means that you're, again, more control means that it's more integrated into any theatrical environment, whether it's straight up rock and roll or whether it's, a very programmed experience for, for end users. And the trajectory engine, built right into the Fletcher Machine remote. A lot of the simple automation that you might need to be able to trigger an object of sound and have it move without an operator having to necessarily drag it, whether it's something you want to add like a rhythmical section where you want to do it some movement based on a tap tempo. The trajectory engine that's built into the Fletcher Machine is set up and ready to go. And it's, it's recallable via timecode or OSC, so it's pretty good. And the one thing I didn't really show yet, but you might have experienced, was the reverb engine. The Fletcher Machine, it doesn't do a modeled reverb on actual venues. It takes a more open approach of, it's a simple to use reverb engine. It's very powerful. The way it's calculating the early reflections and all the time is very unique to what we're doing with Fletcher. And it can be either in this situation where I've got a one-dimensional flat reverb across the front. If I have a three-dimensional space, whether it be on a 2D plane or a 3D plane, I can add all sorts of different reverbs to create more space and time parameters. If I want to make it sound like a reverb, a big hall, I can do that quite easily with our reverb engine. Okay, just quickly, I'm going to run through a little bit of the software overview, and I'm just going to switch computers here and move over to my Fletcher Machine remote here. So I have a remote running here on another computer in my rack. This piece of software is our Fletcher Machine remote, and it is freely available from our website. The cool thing about the remote is you can have two instances running on the network at any given time, and you can set one as a follower and one as a leader, so it means that if you wanted to have a runaround kit, like on a tablet, like I have right here, sometimes when you're doing object-based mixing, being able to walk into the crowd and make an adjustment or into the audience area during sound check, it's really important to be able to listen to this system from different places in the audience. If we're very localized to front of house, we're only getting one unique experience. Right when you open it, you have a dedicated master fader, and again, I can mute myself. That was intentional that time, I promise. We've got our channel listing, or our object listing, here on the left-hand side. I'll use my mouse here. And then our main home window, we can see all of our objects. So if I zoom out, we can see all of these different objects are part of our playback that we just did of all of the different orchestral sounds. On the object page, this is kind of like our digital channel strip now. We have the ability to do EQ, compression. I can do auxiliaries if I wanted to run monitors or external effects chains, as well as my reverb send. So again, here I can take my voice and I can send it to some reverb. It's pretty nice, right? Welcome. And then for all of the objects coming in, you can choose which layer it goes to. And again, these are the different rendering sections of our system. So you can see I have my frontal arrays, my front fills, subwoofers, and my wedges on stage. So I can actually hear myself move around, which is kind of cool. A pretty easily navigatable mixing page. Again, it's just like any other tablet-based mixing application where I can go through and quickly see what I'm looking for. As I mentioned, we do have the ability of having a binaural mix down now with the engine, whether it be the physical engine or the virtual engine that you can load on at home. And again, this also can be used with a USB head tracker. So if you wanted to do any kind of binaural mix with some head movement, you can do that too. The reverb engine is very, very simple to use. As you can see, all of the parameters are quite well laid out. In this case, I have a big room, but I could actually change this to be a single one-dimensional. So if I wanted just to do front reverb like that, and then simple tools like being able to make it larger or smaller and how it decays. On all of the objects in and out, we have our rendering modes. As I mentioned, everything defaults to minimum delay. We can set widths, but this is also available on all of the rendered outputs as well. So there's multiple ways that you can shape how the sound is being rendered out through your system. Very simple tools to be able to add speakers quickly, whether it's directly from the Array Intelligence software or another ad hoc system, being able to quickly deploy a line of loudspeakers and move into a show scenario is quite quick from setup to show. And lastly, we've got a lot of important tools in this last page here. We have the ability to send signal through all of our loudspeakers in our system to quickly find where everything is, calibrate, and all that kind of stuff. We've added a synthesizer in now, so if you are wanting to use some low-end content to be able to really fine-tune a subarray, we now have the ability to use this onboard synth. And then over here in protocols, this is where we can add different things like trackers. Right? So as you can see here, I am being tracked, so as I move around on stage, the audio is going to follow me as I go, and I'm wearing some little beacons here. And then with any of the incoming protocols, whether it's be tracking or OSC, I can also then container those different incoming protocols. So I can assign some kind of movement to an object, and then in here, if I want to, oops, I think in space one, you can see how I've contained myself in this space. So if I go too far off to one side, I'm not going to disappear. I should stay roughly in the same location. So it means that if you do have actors or any movement where they're running off the stage and you don't want to lose them completely, you can use that container to be able to keep them in one place. So with that, I want to introduce you to the one audio tool that's not an audio tool. It's actually something that we've found from the lighting and video departments, and we realize that it's really, really useful for being able to, do this kind of stuff. It's really important that when you're listening to someone that you're keeping eye contact with where they are. So adding something like this tracking has really changed how we can really immerse ourselves in some kind of performance. So we've had Blacktracks come in and help us out with the system here today, and we've invited them along to give you a little bit of an introduction to how the Blacktracks system goes together and how it integrates with us. So Peter Bowman.
Can you hear me? Yeah. Hey, good afternoon, guys, or good evening. Thank you. How are you? Thanks, Jeremiah. Hello, everyone. I'm Peter Bowman from the CAS Blacktracks team. Thanks to the Adamson team and Jeremiah for having me out here today. We'll be diving into everything Blacktracks. I'll start off with a little bit about CAST, get into some of the technology behind Blacktracks, and then I'll finish off with some integrations and case studies. So what do we do at Blacktracks, or CAST, I should say? We primarily have two products, one being 𝐬𝐻𝑜𝐵𝑒𝑟𝑰. What you see is what you get is the acronym, and it's our lighting pre-visualization software that allows you to design your performance in advancement of your production. And Blacktracks is what I'm here to talk about. It's our real-time tracking technology, which allows you to automate the movement of lighting fixtures, media content, or spatial audio. So CAST, we are a local Toronto company. We just celebrated our 31st anniversary. It's a big milestone for a local Canadian company, providing award-winning, innovative solutions to the entertainment industry. In '95, we released 𝐬𝐻𝑜𝐵𝑒𝑟𝑰. In 2006, we released Vivian, which is a simplified version of 𝐬𝐻𝑜𝐵𝑒𝑟𝑰 that was geared towards event planners in the hospitality space. In 2010, we released Blacktracks, and last year we released Converge, which is a complementary software to Blacktracks that allows us to control PTZ cameras. So what is Blacktracks? It's a low latency, real-time solution for tracking. It understands everything in your 3D environment regardless of the scale. It provides the XYZ positional data and allows us to output that to lighting consoles, media servers, PTZ cameras, etc. So we see Blacktracks as a scalable solution. We have it in something as small as a wedding chapel, up to a corporate event, all the way up to stadium or stadium sort of road shows. What we do is it's an active infrared tracking system capable of tracking in real time with a low latency of 7.5 milliseconds and a refresh rate of 100 frames per second. So we can then take this data and dump it into a lighting console, like I mentioned, media server, using the 3D or 6D positional data. We could track anything, be it an animal, prop, human, vehicle, anything that we could put a tracker on, like what I have on my shoulders, we could track. So let's talk about how it works. Essentially, Blacktracks is a collection of sensors and trackers. Around the perimeter of the stage, we have these little cameras set up. They're about the size and weight of a GoPro camera, so really easy to manage. Like I mentioned, they're infrared, so we'll position these around the perimeter. Once we have them in place, now they're going to look for an active LED pulse. So right now I have 2 on my shoulders. Each one of these LED pulses is a unique ID which allows the black tracks to take that information. It also allows black tracks to determine performer 1, 2, or 3, or even where the positioning of the LEDs are on my body. So we can work, so as long as 2 of the sensors can see LED, you could track the performer. It's important to note that it's a line of sight technology, so we have to have a direct line of sight between 2 of the sensors and 1 of the LEDs. So yes, we have a proprietary protocol. So outside of the low latency, high accuracy, and stability, another advantage of black tracks is our protocol, RTTRP, Real-Time Tracking Protocol. And this is what we use to track lighting, audio, multimedia, or PTZ cameras. So let's look at some of the trackables. Essentially, we all want to get to the same endpoint of being able to track talent, but these options will allow us to get to that point depending on the type of performance you have. So our first example would be the classic beacon. This is what I'm wearing, and it allows us to put 3 stringers or LEDs across the body. And typically we would use these for our circus clients, Cirque du Soleil, Disney on Ice, or in this instance, NBA All-Star. Because what we're looking for is redundancy. So as the performer moves throughout the space, if they're flipping, turning, doing dynamic movements, we want to have coverage every time. Our second example would be the mini beacon. Let me just show you this. The mini beacon is a small form factor. It is completely wireless, and it allows us to position it on the body. In this case, we can use it in a custom wrist strap or put it in a mic flag. It requires little costume integration, and it allows multiple people to be tracked. If you have presenters coming on, whoever's holding that microphone at any given time is being tracked. And our final example is the mini beacon wave. Similar to the mini beacon, it's the same form factor, but we can attach a stringer to it. And this is popular with our corporate events because it's easy to put into a blazer or attach to a mic pack and run the cable along the path of the microphone, and then you're covered. So as much as I see black tracks as a automation tool, it's also very much a creative tool. And this brings us to zones. So as the name, it's a proprietary patented technology. It allows us to have some creative flexibility. So we have static zones and we have dynamic zones. A static zone would be an instance where a performer or animal crosses an imaginary line. It's going to trigger an event. It could be an audio cue, it could be a video cue, or a lighting cue. As they cross that line, it's going to trigger that. We also have dynamic zones, which you can think of as like a proximity sensor, because if we're tracking multiple people as they move through the space, if they get closer, it can trigger a crash, any sort of sound you want, or it could trigger a lighting cue or some LED content on a floor or wall. So let's dig into some of the integrations. Today we're here with Adamson talking about Fletcher Machine. Blacktracks as a system is agnostic. It plays nice with every console, every spatial audio engine, every media server. In this case, we're here with Adamson's today. I'm going to show you some examples of what we're doing. So this was a Sleeping Beauty Dreams. We were enlisted to provide some tracking with their spatial audio engine because they wanted to be able to move the audio in conjunction where the performer was going to be. Another example was our friends over at Full Sail University in Florida, where they used spatial audio and Blacktracks as part of their Hall of Fame induction. And here we have an example where we're using lighting, projection, and audio. One of our clients is Feld Entertainment, and this is Ringling Brothers Circus. They wanted to track 85 people. That's the number of performers they have. The issue they were having is because of the large number of performers, when you had a ringmaster or someone speaking or singing, the guests had no idea where to look. So bringing in spatial audio, we were able to have the guests focus because, as you know, the sound moves where the performer is. So that sort of solved that problem for them. So why is tracking important in audio? It's going to ensure the movement with the performer for an immersive experience. It makes every listener feel like the audio is in front of them, and it allows the audience to enjoy an immersive experience rather than a stereo experience. So how do we integrate with Fletcher? So BlackTracks, as we mentioned, it sort of tracks the position of the performer via an IR emitter. We then take this information and dump it back into our server, the BlackTracks server, and then we can send this out via our protocol, which is converted to OSC or ADM OSC. Fletcher Machine will then take that information and direct the sound to the speaker closest to the performer. Some of the benefits of integration: we have a seamless audio experience. It sounds like the audio is tied to the performer's physical location. We have increased immersion for the audience. It creates a 3D sound where the audience feels immersed. Real-time automation reduces some of the manual labor. And then we have precision and consistency. BlackTracks is able to track performers in low light and fast-moving environments, sorry. It even cuts through fog, haze, and smoke. And then we have scalability for complex setups. As I mentioned before, our BTU with Ringling Brothers can track up to 255 unique IDs or 85 people at once. Like anything in live entertainment, anything we purchase, lighting consoles, PTZ cameras, lighting fixtures, it's an investment. So return on investment is huge for our clients. So some of the ways we see that they get the return: we have automation reduces setup and rehearsal time. Real-time tracking minimizes the need for manual corrections. Immersive sounds leads to higher ticket sales or return clients. We're combining two cutting-edge technologies here. So you're making yourself, your system future-proof or ready for the future demands of immersion. And then finally, this results in the ability to leverage cross-departmental budgets utilizing PTZ, lighting, audio, media, etc. So we talked about the integration with spatial audio. I mentioned that BlackTracks is an agnostic system, and like audio, we can integrate with any virtual or physical lighting console. As long as it outputs SACN or ArtNet, we're good to go. BlackTracks can also integrate with any moving or static fixture. In addition to lighting, similarly, we can integrate with media servers of your choice. This allows you to track the projected or LED content in real time. Here's an example of lighting and multimedia. One of our clients is Cirque du Soleil. This is their production of Crystal. So not only are we tracking the performers while they're skating with lighting fixtures, but going back to what I mentioned about proximity sensors, as the performers are moving away and close to each other, it's real-time content that's being generated through Notch and the media server and then projected directly onto that ice surface. I mentioned the agnostic nature of BlackTracks. Well, that also works with PTZ cameras. Any PTZ camera with NDI can work with black tracks, and we can control those as well. Another cool thing we're doing is with lasers, specifically Pangolin and their software. Here's a project we've done with Royal Caribbean on their ship Wonder of the Seas. So as you can see, the lasers are being tracked in the palms and the chest. Historically, to do this, it would take an enormous amount of rehearsals and choreography and precision. But with black tracks, we sort of take that out, and it allows the performers to be a little bit more fluid. They don't always have to hit their marks every time, and the results are pretty cool if I say so myself. Finally, black track servers. So, you know, we don't have a one-size-fits-all approach to our equipment. Essentially, a lot of our clients have different needs, and they're looking for scalability. So some of the things we look at when people come to us, we need to know the space in terms of how big of the space they need to track, because it will equate to the number of sensors needed. We also need to know how many integrations they want at once. Do they want media and spatial audio, or PTZ and lighting? And then trackables. How many people do you need to track at once? Once we have all that information, we could sort of put together something that is going to work for you. As our clients, their needs, as their needs grow, a lot of the times they'll just need to swap out a server and go up a level, because all of the accessories sort of, they're all interchangeable. Just want to give a shout out to Jeremiah and the team at Adamson's for allowing me to speak here today. I hope it was somewhat informative, and I appreciate your time. Cheers.
Thanks, Peter. Okay, I mean, that pretty much brings us to the end. I think I have one other track that I can play. I do have a microphone that if you wanted to like walk around and listen to what it's like with the wedges up here, you're more than welcome to do so. Also, if you have any questions, I'll be around for a few moments after this if you want to ask me anything specifically. But I think I'll just play one more track, just in Spatial. It's very much designed for spatial audio. In fact, I think it's actually been produced by our team who built the spatial audio engine, and it's a typical kind of soundscapey electronic piece. But other than that, I really thank you everyone for coming to this and giving your Tuesday night to listen to us talk. It's all really, really cool stuff, and if you go to school here, I really, really do encourage you to get involved and start to utilize this system. It's pretty amazing. So, thanks again for AES for having us too. Really like to be involved with the Audio Engineering Society, both here in Canada, but also around the world. And again, thanks to the TMU staff, Scott, Jasmine, Finley, and all of the students and technicians here that helped put the system in. It was a good time putting it in. Yes, Anthony. We do. Questions. Oh, you're going to put me on the spot. Please ask me some questions. We had another microphone right here. This is, but I'm going to give it to you without the tracking. Okay. Please make them easy questions.
Easy questions. I have hard questions, only hard questions.
Excellent.
Okay, all right. I saw your hand first.
Thanks, Anthony. I'm wondering, have you taken this concept and also expanded it in a different venue to do sides, back, and to really be able to increase that census?
Yes.
Yeah, you know what I'm talking about.
Yeah. So we're only showing the system that's actually been installed here. Again, an investment on a large system that would do a full 360-degree encapsulation is, it's a lot. There's a lot more speakers involved. But all of our engines, they can deal with multiple levels of rendering. So it's not just like this would be a one-dimensional, frontal system. We can do two-dimensional surrounds. But we can also do multiple elevations, so we can do like a 180-degree dome if you had the time, money, and loudspeakers to do so. And again, up to 128 objects in and out on the maximum machine.
So I think this is an easy, non-technical question. I might know the answer. Why is it called the Fletcher Machine?
It's an homage to the Fletcher Machine curves, and Harvey Fletcher, who's the father of stereophonic sound. He did a lot of research on hearing aids and all of these different concepts that have become, part of everyday audio life. So that's where the name has been derived from.
I got a question down here, but I'll ask a question while I walk. If you have a mixing console, how does traditional mixing integrate with these objects? Am I doing direct outs, and each direct out goes to
so glad
an
you
object?
asked.
Or, tell me about the.
Let me
do the signal routing.
You're doing the bit that I forgot to run through because there's a lot again to talk about.
Yeah.
In this situation, I have a 𝐷iGiCo mixer because 𝐷iGiCo and Avid are the two consoles that currently have built-in integration plugins. And again, I'm most familiar with the 𝐷iGiCo, so that's why this is here. We're taking all of our input sources. In this case, I'm running USB for my playback, but it could be whether it's all the microphones coming in from your MADI stage box here. Each source is hitting the gain stage and the channel strip for every single channel discretely, and then essentially we're taking it the post-fade direct out. So I still have the ability to grab a fader and mix with my comfort level, but then from there, the direct out, it doesn't actually hit the two-track busing on this, it goes straight to the Fletcher Machine via MADI or AVB.
Are you able to just take the control of the, like an OSC fader level instead of passing the audio through?
So with the 𝐷iGiCo console, I can show you using the remote control, which is mirrored to my console currently. There is a Fletcher Machine plugin here. So basically actually I can do this right from the very beginning. In the external control section, oops, let's see overview. In the external control section, there is the ability to add multiple different kinds of spatial audio controls, whether it's us or another brand. AFM stands for Adamson Fletcher Machine. Immediately, straight out of the gate, when you set it up, it asks you to choose a fader that can map via OSC the master fader. So again, I do have I'm using one of my control groups to, as a main handle. I could use my master fader if I wanted to. And then from there, it's not showing it here because this is the mirror, but I enter the OSC address and the port in and out to be able to control it. On the Fletcher Machine, we have an integration section. So again, I can use all of these integrations at once, and this isn't even looking at the tracker. This is just looking at the 𝐷iGiCo, where again, I can add the console IP and the in and out port. And then I've also enabled it to fire the snapshots. So when I'm firing a snapshot in my Fletcher Machine, the console is actually following it, so everything is in sync with one another.
We got a question here.
Yeah.
Hi. So I remember in the beginning of the presentation you had the directivity values for the line array. So you had something, I guess, was 15 degrees in vertical and then 100 degrees for horizontal, minus 6 dB. So I have two questions about that. One is, what is the frequency range for that? Is like the entire spectrum that you have for the sensitivity, you also have that, or is it something a little bit more restricted?
Yeah, so the spec sheets for the loudspeakers themselves. The CS7s are doing full range down to about 100, to 60 to 100 hertz, depending on where I've got the crossover set. And then the subwoofers below are doing from 80 down to 20 hertz. So the directivity that you saw, that 100 by 12 and a half, that's the directivity of the loudspeaker itself. So they're 100 degrees horizontal, which means that we've got quite a bit of overlap per speaker, which is ideal for a frontal system or any kind of spatial audio system. So when you get the handoff between one stack of speakers to the next, that there's some overlap between that. And the vertical coverage is, they're all stacked together so that 12.5 degrees gets stacked and then manipulated using our array intelligence software to design a set of angles. So you can see this line array has a bit of a curve to it. But if you were to look at these up close on the ground, you can see that all of that geometry is adjustable based on the geometry of the venue and the coverage, the vertical coverage pattern that you're looking for.
Yeah. I was referring to the -6 dB drop. Is that for the entire frequency range you have there? A maximum of -6?
I see my colleagues pointing at himself. He's going to jump. You going to jump in on that, Brian?
Yeah, you can answer it, absolutely.
Phone a friend, it's always best.
I can just, so basically the -6 dB refers to, you can either express it as -6 dB or ±3 dB. And what that's saying is that basically within the scope of ±3 decibels, we are stating a nominal directivity in the horizontal plane of 100 degrees. And in reality, that's carried down to about 250 hertz where it becomes omni. In the vertical plane, 12.5 degrees is expressed as the arced frontal, the arc of the wave front emitted by the high frequency sound chamber. In the lower frequency, it's an omnidirectional source, and the vertical directivity is a defined function as a result of the length of the actual line array.
See? This is why we come to the AES meetings. And please, he's right there. Have a conversation with him after the show. We've got another question up front here.
Hi.
Hi.
Does this support third-party plugins, audio plugins of some sort? And what I'm thinking of here is perhaps a waves reverb, where the performer would have the voice processed by the waves reverb, so it's emanating out of all sorts of speakers in a proper immersive format.
There's no direct plugin support in the Fletcher engine. If you were talking about doing something like that, you would need a console or a Waves server and a console to be able to do something like that.
Okay.
Reverb-wise, we tend to want to rely on the reverb that's built into it.
Okay. I'm right here, and I'm obsessed with feedback. I like to say negative feedback is how the audio industry functions.
Everyone gets a solo.
That's a very deep joke for those who study electronics. If I create feedback, like why doesn't that feedback? Is it the processing time? Is it proximity? Why can I stand right here and talk into this speaker? Is there anything for feedback control or anything of that sort? There you go.
I mean, when you make a high-quality loudspeaker that has good gain before feedback, ideally when you put the microphone in front of it, it's quite stable.
Is having many smaller speakers have an impact on that response? I know, it's not very good, so I want to answer.
It depends.
Okay.
I'm going to say no because most of the loudspeakers are pointing at the audience where there's less microphones.
Yes.
On stage as a monitor engineer, you're out of luck there. You're going to get feedback no matter what.
I got a question here.
Hi, how's it going?
Good.
I just had a quick question. I was just wondering, is it possible to run this system like in a parallel sense where you still have the stereo field, but then also blend this surround so that you have like an even, sound field, and then possibly just kind of blend in this kind of cool.
I've seen some people do it. It's not out of the realm of possibility. The limitation is really what speaker setup can you provide. So in a lot of cases, being able to do a stereo with some fills around it, that could definitely work, and our engine can definitely handle that processing. Is it the best spatial audio environment? Not necessarily. Typically when we're designing a spatial audio system like this, you want most all of the loudspeakers in the system that are going to be main loudspeakers to be of equal level and equal power. So you get the same localization no matter where it is.
Another question here.
Okay.
Hey there. So in this configuration, obviously it's a one-dimensional line for the speakers
A frontal
across
system.
the stage.
Yep.
But I noticed that when you were walking around, the object was tracking not only your left-right position, but your on-stage depth.
Correct.
And so is there processing happening to give a sense of that depth? Can the depth just go sort of to the front of the stage and back? Or
Yeah,
so for example,
I
if you
can
walked into the crowd, would it do something?
Yeah, I can demonstrate that. So basically what's happening is it's working like a lens, right? So if I were to stand really close to one loudspeaker, it would probably localize just that one loudspeaker. If I move further back, the localization gets less and less, but it's, again, I'm working like an aperture lens. So the further back I move, the more even the coverage between all 5 loudspeakers is going to be. You're going to hear some movement as I move left to right. You'll get the sense of movement, but it's not as discretely localized. But then again, if I want to create that, you bring the closeness. Again, if I come and stand right at one loudspeaker, again, I'm just localizing to this area. So you can use it as a tool, or you could avoid it if it's not something that you want to go for. So again, when you're making those decisions, when it comes to musical mixing, you can play with that front to back depth to create some depth, right? Typically, we'd do that with EQ and compression and reverb in a stereo mix. Now it's just, if something doesn't sound like you want it to sound, sometimes just moving its position before you EQ, compress, or do any other dynamical change like that can change how it fits together, right?
Oh yeah, I call it that the smooge factor, right? It smooges out as it goes backwards. Another question back here.
Yep.
Hi. Is spatial audio in professional audio different than the consumer audio? Like when you are, sorry.
No, go ahead.
Like when you are doing the demonstrating between stereo and spatial audio recording, I didn't hear the difference between the localization of individual instruments and the spatial, like the spatiality feelings been different?
I mean, the technology is the same. The difference on the consumer end is that we're sold a container, right? So for example, when you buy into spatial audio in the consumer world, you're sold a brand of a container like Atmos. The technology behind Atmos is very similar. It's all object-based mixing. It's using time and amplitude and those kinds of calculations to place an object in sound. But again, consumer, it becomes a brand name. But the technology is the same. Again, we're doing binaural, which is very similar to what you would get with the HRTF tracking with the Atmos, the Apple headphones and stuff like that. But this is designed really just as a quick, like a fast mixing tool that's more hands-on than a studio environment. So,
real time.
Yeah, this is all about the real-time aspect of it.
Hi. Second question. You talked about 2 different modes. I forget the names of them right now.
Yep.
But could you talk a little bit more and maybe demonstrate? And I'm wondering if that's on a system level or like a source.
I can try and demonstrate it, but it might not be finite enough to hear it. But basically, we've got 3 rendering modes as standard, and I can show you the settings in here, just so you can get some.
Is that something best experience on stage, maybe? Like, is now a good time to...
Possibly.
Sure.
I'm feeling a little put on the spot here.
No.
But as far as what I was mentioning with the rendering modes is that there's 3 modes. There is amplitude-based panning, which is just using level per speaker. There is full time and amplitude, which uses all of the exact path lengths from the physical object to the physical speaker, not just X and Y, but also some Z axis as well. So those are the two ends of the spectrum, but we've come up with a middle ground, which is the minimum delay, where we basically truncate the closest time from the rest of the path lengths to each speaker. In fact, here I can pull up this slide real quick. Right, so you can see where that arc is happening. That's kind of what the minimum delay is doing. So that first time arrival, it's calling that useless information because we don't want to add that extra time to the object. Remember, there's already about 1.3 milliseconds of latency on the actual processing time, and then most digital loudspeaker systems have another 5 to 6 milliseconds already. So subtracting that means that you're going to get rid of that and gives it that much more close feeling for the live environment. If you're going for something much more accurate, and again, you probably have to have really, really high resolution and a lot of moving spaces, that's where you might want to use something like the full time, which is full delay. And then for things like subwoofer lines, you might want to go down to no delay. Say if you've got a bass guitar and a bass drum that you want to have extra punchy and fat, you don't want to necessarily have the localization minimize the amount of power that you want. So you could go down to removing the time calculation out of the spatialization, playing with the front to back depth to be able to work the subs like an arc sub array, like so.
I'm 30 meters back, and I am 30 milliseconds away from my mouth. That's why I sound like this when I'm talking, because my brain is faster than my ear. Yeah, that's the way. Is there any way in the tracking system to remove myself from hearing myself so I have a more intelligible speech?
Earplugs?
Earplugs.
I mean, right now you're outside of our tracking bounds, even if there
Okay.
was something we could do with tracking. But yeah, in this
Is that
situation,
an application that you foresee for this this experience?
that's outside of my current scope of work.
There you go. Okay. That's why we're here.
That's my answer. I'm
Yeah,
sticking
that's
to
good.
it. I mean, if this was a two-dimensional 360-degree loudspeaker system,
Yeah.
that microphone would have a tracker on it. I would have a confidence speaker here so I could hear you, but you would hear yourself over there closer to where you are. Like me on stage, I'm hearing myself through these wedges to get over that, echo effect of the room.
The slap.
Yeah, add more people, that helps. That
Yeah,
something to soak
meat
up.
bags.
Yeah, exactly.
The meat bags. Yeah. Any other questions, folks, before we... Yeah,
We'll go one more down.
Got a question here.
Got a couple.
Right.
Hey, Bill.
Any other speakers outside of your system running in the hall at this point?
No. But thanks for asking. There are older speakers that are on the walls that have been part of the theater for quite some time. It would be great in the future if we can leverage those, but I believe the wiring is such that they're in duplicate, so we don't get the resolution that we'd want. But yeah. Hey.
Hi. Yeah, just a question, because it was mentioned that there's like events that can be triggered depending on where you are on the stage. First question is, like, can you automate something so depending on what zone you enter on the stage, like an effect would be automated to turn on, like a reverb?
Oh,
if
in
you
the
walk
tracking
over to
system?
Yeah, while it's being tracked.
Yes.
And how hard would that be? Like, if it is possible, how hard is it to set that up? Like, what is the process?
So only a small portion of that would happen within the realm of the audio world, right? And that would be the reverb turning on and maybe level adjustments, right? But as far as the rest of that goes, the zone and collision stuff's happening within Black Tracks. Black Tracks talks many, many different formats, so you can take that, say, the ADM OSC output of that and run it into something like Touch Designer, QLab, or any other OSC program that can trigger some logic to then be able to do some of those more complex things. The Fletcher Machine is only dealing with audio. It's very much open to accepting other formats of control to be able to trigger things like, I'm going to start, like if I have a button press, for example, on an OSC that sends an integer, that might send a mute on command, so it goes from mute to on, and at the beginning of that channel being turned on, its own internal trajectory engine can trigger. But as far as doing collisions between things that are happening in the tracking world and having them trigger other things, you would still need some other software to be able to make those happen. But again, once those, the logic has happened and the triggers are sent, we can receive those triggers to be able to action some of those tasks.
It seems like Adamson is turning into a software company in addition to being a manufacturer. What are some of the challenges of having local talent or international talent contributing to the software that you're building?
Ooh, what are the challenges? I mean, everything's a challenge, and everyone is moving more and more towards software because it's that seems to be the way everything's going. We've always been in software. Again, we were one of the first loudspeaker manufacturers to come to market with a design software, and we've been doing that for probably nearly 25 odd years now, I'd say. As far as becoming a software company, we like to say we've got 3 brushstrokes: loudspeakers, power electronics, and then software, and they're the 3 parts of the audio system that are most important to us.
The Trinity, I get it.
Yeah.
Folks, 'tis the time. Jeremiah, if you've got an on-stage demonstration, I think now's the time. I figured I'd thank everybody while I have your attention here. Thank you to TMU, and thank you to Finley and Scott and the team here. Let's give the team a round of applause. And again, thanks to Adamson. It's amazing that our neighbor is building this kind of stuff in Ontario. Thank you, everyone, for coming out. I think there is some pizza still, so if it's warm, it's a meal. If it's cold, it's a snack. So help yourself to a snack on the way out. Jeremiah, you want to add one thing, or?
No, I think I'm just going to play one more track.
Yeah, let's do another playback.
As
Thank you,
people are
Jeremiah.
leaving, and
Appreciate
then again, thank you so much for coming.